Good morning, ladies and gentlemen. Let's talk about electroscope. This is an electroscope. An electroscope detects charge.
Saw this in the video yesterday.
And there's this metal part, and then it's surrounded by an insulator, so the charges can't escape through there. They just go straight down through the insulator. And then at the end, they've got these gold leaves, kind of like this.
Right here.
And so we're gonna go ahead and go through some questions with you. What happens when you rub a negatively charged balloon across the knob of the electroscope? So here's my balloon. It's negatively charged.
Okay, so the balloon had electrons on, negatively charged because it had electrons. And what happened?
Well, when I touched it onto the conductor, the knob, right, the metal knob, the electrons escape from here and they run down through the conductor here, all the way down to the bottom, right?
Yep.
And well, now there's way more protons than electrons at the bottom. It's negatively charged.
Way more electrons than protons.
Oh, what did I say? Protons?
Yeah.
Wrong way. Opposite. Okay.
These things happen.
Way more electrons than protons, and now they're repelling each other, right? Because same charges.
Those leaves are free to move within limits, and so they repel each other.
Okay, so that's what's going on there.
This
is called charging by conduction, and it happens when a charged object, touches an uncharged object, which was the knob, and we transfer the electrons from this charged object to that charged object.
Yep. Charging by conduction.
Okay, when electrons are placed on a conductor, they move around to get as far apart from each other as possible, and we saw that here, right?
Yeah.
The electrons go from the balloon to the conductor, and they run through it, and they're trying to get as far away apart as possible, so they go all the way down, and then the leaves are separating.
And so the electrons are evenly distributed everywhere on that conducting rod knob and the leaves at the bottom. And on the knob, there are excess electrons. Where do you think they are? Do they run all the way through the knob, through the metal of the knob, or are they just on the surface? Which would allow them to be farthest apart?
They would be all the way through it. I mean, right?
They would. Well, there are electrons all the way through it, but the excess electrons are on the outside of the knob. Why? Because that's as far away as they can get away from each other.
No, that makes sense, Boykin.
Yeah, so they're on the outside.
They're trying to spread apart.
The excess electrons are on the outside. That's right.
Okay. Grounding. Should we show them first?
Yeah, show them.
All right, I was like, let me see.
So you've got a charged electroscope here.
It says grounding. Electrons move into or out of a large reservoir of charge, aka you or the earth. So I can ground this bad boy.
Yep.
Okay.
So the electrons went into Ms. Mo.
Yeah, they move into me.
Because you're a large reservoir of charge.
Okay. After grounding the electroscope, with your finger, bring the balloon close to. Oh, wait, let's talk about what happened there, right?
With the grounding.
Yeah. So, I mean, we just touched the knob, and so the electrons can now run through me.
Yeah.
And essentially back into the earth.
Yeah.
Because I'm touching the earth.
Well, they can stay in you because you might only have like 1,000 excess electrons in the electroscope. I'm speculating here.
Yeah.
And 1,000 extra electrons in you is nothing because there are many moles in you.
Yeah, it ain't nothing. So, okay. And keep in mind, the protons are not moving. It's only the electrons here.
That's right.
Okay, so after grounding the electroscope with your finger, bring the balloon close to the knob without touching it.
We would like for you to be in the room and doing this yourself, but...
Okay.
Those leaves move apart even though, and then you move them away and they go back down. Okay, we need a model to explain what's going on there.
Good, okay, I didn't charge it. All right, so, should we talk? No, we're going to
So they should stop and watch this video, and there is a study guide that goes with it.
Yeah, so you go ahead and go to the video down below, watch the video, and you're going to do the video guide with it, okay?
All right.
Okay, pause it, come back, Okay, now that you're back.
Now we're back.
Now we're back. Okay.
It's magic.
Okay, so induction. You guys learned all about induction. Here is our definition for you. Electrons are persuaded, okay, to move away from their neutral atoms by being attracted or repelled.
Yeah.
Okay.
So that's what's happening here.
Okay, so how does that manifest itself on our electroscope? So here's our question. Here's what happened. The leaves on the electroscope spread apart when a negatively charged balloon gets near the knob, right? So we had our negatively charged balloon. It's getting near the knob and they're spreading apart.
Yeah.
And we know it has to do with induction here. When the leaves on an electroscope spread apart when a negatively charged balloon gets near the knob and drops back when it's taken away. Why? What is happening here?
All right. We want you to answer this question.
And you can't just say induction. You got to explain what's actually happening here.
Yeah.
Okay.
Go to the next slide.
So now that have you written your idea?
No, we're asking him to do that now.
Okay. So now you're going to we're gonna do the old right to revise. However, for this part, we're not gonna have as many steps. What I want you to do is take some time to do your quick write.
Do a quick write to explain what's going on with the
Yeah.
balloon. When you bring it close, the leaves spread apart. You take it away, it goes away.
Why and why? Tell us the why. So take a minute, 2 minutes, 3 minutes, 4 minutes to do that. Okay, you're gonna pause this video and do that.
And then we'll talk about it, and we'll ask you to make any changes.
Okay.
All right.
All right. So now that you've written your quick write, we're gonna have to skip the share part. Let's go ahead and just jump to the teacher explanation here. So the question again was the leaves spread apart.
Okay. So what's going on?
Okay. So as I rub my shirt on the balloon is now negatively charged. Yes.
Yeah.
Okay. And I bring it close to here. And the negative charge on my balloon is scaring the electrons in my knob here down, them making it run away.
Yep.
And it's exposing the naked protons in my knob here.
Yep.
Now, as I scare away those electrons, they're now going down here, and the two leaves down here are becoming negatively charged overall.
Yep.
Okay.
And they spread apart because of force of repulsion.
Yeah, and so then when I bring it away, okay, now the scary negatively charged balloon is gone. The electrons are no longer being repulsed, so they're now attracted back up to the protons in the knob.
And everything's neutral again.
Yeah, and so what do we call this?
Charging by induction.
Charging by induction.
Well, we're not charging. We're inducing.
We're
inducing the electrons to move because they're repelled away.
Yeah.
Okay.
So,
Did you get that?
did you get that? If you didn't get it, rewatch it
Yeah.
in slow motion. Okay. All right. So my next question for you is, why does a negatively charged balloon stick to a neutral wall?
Yeah. And we'll see if you can figure that out by the time we come back tomorrow.
Okay. For your homework today, you're going to do page 507, number 2, and number 4.
All right. These are conceptual. Have fun with them.